Hey everybody, this is your pre-calculus 5.2 video on one-to-one functions and inverse functions. So to start with the y part, didn't you ever wish you could undo something you had done? Using a computer you can do Control-Z sometimes. Inversion covers MRI image reconstruction, geophysical reconstruction, Muon Imaging, etc. Muon topography, which is an imaging technique that Los Alamos scientists pioneered in 2002 following the 9/11 terrorist attacks, uses the muons to detect and identify nuclear threats. Such as uranium and plutonium, based on their atomic number and their density. Unlike other imaging and detection techniques like X-rays, muon cannot be fooled by threat materials that have been shielded. In this lesson, you'll see that if X repeats, it's not a function, and if Y repeats, it is a function, but it's not one-to-one. So your objectives, again, are to determine whether a function is one-to-one, determine the inverse by a map or set of ordered pairs, meaning like a mapping, like they could do something like that with different numbers that would be one-to-one. But if it's like that, if this goes to two things, that's not a function. And if you have one like this, that is a function, but not one-to-one. So a lot of this y'all probably saw a long time ago. You also want to be able to obtain the graph of an inverse function from the graph of the function and find the inverse of the function by an equation. So the equation part is where you're going to probably set x equal to y and solve. Now the reason why we're doing this is because we're about to go into logarithmic functions and exponential functions, which are inverses of each other. But yeah, section 5.2 is probably kind of easy. There's four ways to represent a function. You have a map with arrows, like what I did. You have sets of ordered pairs, like you do a curly brace, number like that, and so on. You could also say a graph or an equation. If no two elements in the domain, like not two x's, correspond to the same element, then it's one-to-one. So if you do have two different inputs going to the same output, then it's not one-to-one. It's only one-to-one if when you do the function to this one, then it's not the same as the function to that one. Another way to describe it is to use the word image, which relates to range. So a function is one-to-one if no y in the range is the image of more than one x. And it's not one-to-one if two different ones correspond to the same. Remember that we use the vertical line test sometimes. You can also use the horizontal line test to determine if it's one-to-one. So like not only would it be a function, but the inverse would also be a function, which is why it would be one-to-one. And then we're also going to talk about a function that's increasing or decreasing on an interval. So x squared is not one-to-one because that would fail the horizontal line test. So it passes the vertical line test, so it is a function, but it fails the horizontal line test. So for example, you could have 2 going with 4 and -2 going with 4. The 4 repeats, and so it's not 1-to-1. Determine the inverse by a map or set of ordered pairs. Basically, we're just going to switch the x's and y's. So the domain of this one equals the range of that one. The range of that one equal the domain of that one. If you do f prime first of f of x, then you get x. And if you do f first of f1, f -1, then you also get x. So if you do get x for both of them, then it's going to be called invertible. In other words, it is the inverse. And here it's just talking about switching x and y, but it's using a and b. It does reflect across the line y equal x. And we're just going to switch x and y and then solve. Which is basically what it says here. And then sometimes you may want to restrict the domain which means like limit it to where it's either increasing or decreasing, but not both. Because the absolute value graph would fail the horizontal also. So unless restrict domain to like -infinity, 0, or 0, infinity. I guess I put that here with brackets for the zeros. Okay, well that's the general part. I know we kind of went over that a little fast, but here's the problems. So f of 8 equal 3. So remember, the normal thing would be f of x equal y, which means 8, 3 is your ordered pair. Now, if you do the inverse of 3, then that's going to be 8. And it's multiple choice. Okay, on this one, is it 1-to-1? They are unique x. And you got 6, 9, 3, 5. It's also unique y. And so then it's a yes. On this one, it does pass the horizontal line test because this is getting closer and closer, but it's still going down a little bit, you know. So that's going to be yes. The horizontal asymptote doesn't mean it fails the horizontal line test. Okay. Same thing here. Even though you have a horizontal asymptote at 1, it passes. I'm just putting same. Okay, now we're on the one where you have names of the player and you have your points. So for the inverse, you'd need points and then the player. Now, both of these have points, then the player, but what you notice is that 168 corresponds to Tim, and here it says 168 corresponds to Amy. Which cannot be the case. It has to be like that. So then the domain of the inverse would be the list of numbers. Apparently this is multiple choice, so it's easy. And then the range would be the list of names. Okay, now they want you to say the inverse from your list of ordered pairs. So for the inverse, they're going to have the y's as the x's. So y becomes the x. So they basically just reverse the ordered pairs. So if you have x to y, or x comma y, then that becomes y comma x. So -3, 13 becomes 13, -3, and so forth. Make sure you put commas between them, and make sure your parentheses close. So then your domain would be the new x's, which is like the original y's. And these would be your y's, which were your original x. Okay, now we have to see whether these are inverses or not. Now, one thing you can tell is this one's multiply and this one's divide by 3. And this is add 4. And this is subtract 4. And so if I had to just guess based on those operations, I'd say yes. But I'd want to prove it because of the parentheses. Want to prove it based on the parentheses. So when we're doing f of g of x, we'd start writing our f function and leave a space and then put +4, and then we plug this in here. So then -1/3 times -3 cancels, and so then you get x minus 4 plus 4, which is x. In other words, I would not distribute first because that makes it harder. Don't distribute first. And then for this part, oh, and by the way, this is linear, so the domain is all reals. This is also linear, and it's all reals. If you want to double check that, that's probably a good idea. And we can also show how the graphs are related. -3x plus 4, there's that linear graph. And then -1/3 parentheses x minus 4. There's that linear graph. Now what I was saying was, like from the notes, if we put just x here, then you're going to see how these correspond. They're mirror images based on the y equal x. And so if that's the case, then it would be the inverse. Okay, so this time we're going to do the, well, we need to say no values are excluded from the domain. Okay, because they're both linear. Since both are linear. Well, let me just say, since both have domain, all reals. Because we've seen before other ones have all reals also, like x squared and absolute value. Okay, so now we're going to do g of f of x. So we have -1/3, and then we're going to have something, and then -4. So again, that's start writing the g function, leave a spot for the x part, which really turns into negative 3x plus 4. Okay, so again, let's start writing g. And then substitute f for x. And what I'm going to do in this case is just drop my parentheses, and we have plus 4 minus 4, which cancels. And then this cancels, so you're left with x. So again, on this it's linear, so it's no values should be excluded, and it's a yes since both answers were x. If you have anything other than x, then it would not be. Okay, so now on this one we have x to the third, and then we have the cube root of x, and we have a minus 6, and then we have a plus 6. So it's probably a good candidate that it is an inverse, but let's prove it. So we start writing the f function, which is something cubed minus 6, and then plug this in here. And then cubing something that's cube root cancels it out, so we're just left with what was underneath, and so that's how we get the x. And there's no values excluded for that, because when you go into x to the third minus 6, well, I need to move this down a little bit. Yeah, you can see that it's going to be all real numbers for your domain and your range. And then on this other part, if we did the third root or cube root of x plus 6, that's going to look like that, which again we'd say all reals for your domain and range. And so that's why on these parts it should say no values excluded. Now again, to do the g function first, we have the cube root of something plus 6, and then we just plug in the other function x to the third minus 6 here. So now I'm just going to drop my parentheses, and negative 6 plus 6 cancels, so you just have the cube root of x cubed, which is x. And since we got x on both, then it's a yes. Okay, now on this one, we're doing f of g of x, and so we start writing our f, and then we substitute g for x, so we have 3x minus 4 over 5 minus x, and 3x minus 4 over 5 minus x plus 4. Not that. Hold on. Plus 3. Okay. So what we need to do then is to get a common denominator. This was 5 minus x, by the way. We want a common denominator, which will be 5 minus x. And so on the front part, we're just going to keep that alone. But on the back part, we need 4 and then 5 minus x. Because if we're going to have it downstairs, we have to have it upstairs. That's how it works. And then on this one, we want 5 minus x to be our denominator. And we leave our 3x minus 4 there. But then we have to say plus 3 times that. Now, whenever these are in corresponding positions, they are going to cancel. You could think multiply your extremes and your means and then cancel them, or you could just say they're in corresponding positions. And then this is going to be the numerator. So this will be 5 times 3x is 15x. 5 times negative 4 is negative 20. And then plus 4 times 5, which is 20, and then minus 4x. Now over here, I get 3x minus 4, and then plus 15, and then a minus 3x. So one of the things I notice is that the negative 20 plus 20 cancels. And I also notice the 3x minus 3x cancels. So then we have 15 minus 4 is 11. So that's 11x. And negative 4 plus 15 is also 11. Then that cancels and gives you x. So it does work out to be like the others, but it was more work. Now if you think about the domain, for f, this would be all reals x naught negative 3, and this would be all reals x naught 5. So remember whenever we did f of g of x, you need your g domain and your f circle g part. So the g part is the x naught 5, and then this part would be all reals. And so then your answer would just be the, that part, the 5. Now we're going to do the same thing on this one. We're going to do the g function. So that's our skeleton template, or whatever you want to call it. That's the function without the x's, and then we put the other function in there. So this was the g function. Now substitute f for x. And so we have 5x plus 4 over x plus 3. Okay, so then to get our common denominator, we keep the numerator the same for the front, because that's already covered with the x plus 3. But for the back part, we need minus 4 and then the x plus 3. Why we're allowed to do that, remember, is because x plus 3 times x plus 3 cancels. Pause this for a second. Okay, and then on this end, we need our x plus 3 for our denominator, and we would need 5 times x plus 3 like that for it to match. Because whenever it's the same thing on top and bottom, those cancel to 1. And then this end, the best way is probably just to keep the minus and then the parentheses. You could distribute if you're into skipping steps, but that's probably not the best approach. And then this one and this one cancels, and then we get 15x plus 12 minus 4x minus 12. So the 12 minus 12 cancels. And on this part, it's 5x plus 15 and then distribute the minus, so it's minus 5x and minus 20. I didn't mean to write 15 right there, I just meant to write 5. So then your 5x minus 5x cancels, and so then we get 15 minus 4 is 11, so 11x. And again, I don't know why I distributed that. This should just be minus 4 right there. I guess I got distracted. 15 minus 4 is 11. So then your 11 over 11 cancels, so you get x. So both of those did work out to get x. And then since we were doing G circle F, you have to use your domain of F, which was the x naught negative 3. And then the x domain for this would be all reals, and so then your final answer is the negative 3. So even though you just ended up with x, doesn't mean you can say no values are excluded. And then because we did get x for both of these, then it's a yes. Okay, on this one, what we're doing is we're going to have a graph, and you switch your x and y. So if this is negative 3, in your original, then your inverse would actually be the same thing. And then on this one, if it's negative 2, 1, then the inverse would be 1, negative 2. And on this one, if it's 1, 2, then this is 2, 1. And then if you have 2, 5, then you have 5, 2. So notice all you do is you switch your x and y. So then you're going to pick the right graph, and it is going to be a mirror image right down the middle, and so it's that one. It's a mirror image across y equal x. And if you want to double check your ordered pairs, there's the 5, 2. There's the 2, 1. There's the 1, negative 2. And there's the negative 3, negative 3. Okay, now on this one, there's not any ordered pairs given, but it's basically got to be the perfect reflection across y equal x. Needs to be the perfect reflection across y equal x. Because the reason I'm saying that is because this one does not look like that, because this looks like a different spacing than this, but this is what we want. And then these are not really close. Okay, now on this one, it's telling you that the function is 1 to 1 and to get the inverse. So if we have y equals 6x plus 3, to do this algebraically, we would say switch x and y and solve. So it's x equals 6y plus 3. And then we would just subtract 3 and then divide by 6. Now what they did is they said x over 6 minus a half to cancel it. We could have said that excuse me, or we could have said 1/6 x minus a half. And then you would use your graph of both, and it'd be this one. Again, reflecting across y equal x. And then for this one, we have 4 over x minus 5. So we'd say x equal 4 over y minus 5. And we have to solve for this y. So what we do is we switch these positions, because you multiply by y minus 5 and you want to divide by x. And so what they do is they switch places. And then you just add 5. Now that's how I do it, but what they did is after this step they got a common denominator and then said 4 plus 5x, and then they reverse these, so it's 5x plus 4. I bet it would take any of those three, and then you just gotta graph it and see which one matches. Four over x minus 5. There's the original, and then 5x plus 4 over x. There's the other one, and then it reflects across y equal x. So now you can see those match. Now, if it's pretty unclear here, what you can do is you can look at your table and jot a few ordered pairs. So on your original, I notice I go 1, -1, 3, -2, and 4, -4. And so on my new one, it should be -1, 1, -2, 3, and -4, 4. And so let's, verify that. So if we go to -1 and go to this one, to the red column, notice I'm in the red column, then it worked. Go to -2 and it's 3. Go to -4 and it's 4. So that's the red column. Okay, so that does match. And then the graph was the B graph in my case. And then looks like we have a couple more. Again, on this one, we want the inverse. So if you have y equals 7 over x and x plus 4, then it's x equals 7y and then y plus 4. Now this is probably a little bit trickier one. What you have to do is multiply this out. And then you're going to want to distribute. This one looks like a lot of steps. And then you want to put your xy on the same side. Then factor out your y. Whoops, this is 4x. And then divide. Now, this is really the same as this, because if you multiply the denominator by -1, it would be like the same thing. So that would that'd be counted correct by Math Excel. So going back to what we said earlier, this one's a little bit harder to just say, oh, I was multiplying by 7, so I divide, and I add 4, so I subtract. That's harder on this. So take your time and go through this. You switch X and Y. And then you solve for Y. So that sounds easy, but what we had to do in this case was distribute. And then we want Y on the same side. And then we needed to factor out the Y. And then we had to divide. So that really was a lot of steps on that one. And then our last one, probably something similar. We have y equals 6x plus 8 over x plus 3. So our first step is say x equals 6y plus 8 over y plus 3. So again, that was switch x and y. And now you want to multiply. So I'm going to call that get rid of your denominator. By multiplying by y plus 3. And then we want to distribute. So you get xy plus 3x. And then you want to combine your terms to the same side of the equal. So this would be, if I bring this over, I'd have xy minus 6y plus 3x equal 8. And then I want a minus 3x, like that. And then you want to factor out your y. So this would either be 8 minus 3x, or you could say negative 3x plus 8. Those are equivalent, so I'm going to just put it as negative 3x plus 8. And then we divide by x minus 6. So then your answer is negative 3x plus 8 over x minus 6. And that is the same as that. Negative 3x plus 8 over x minus 6. Okay, so there's your video for all those problems. I hope that helps. Have a good one.